Hello everyone. Today we're going to speak about Internet Protocol IP, and my name is Hariswaran. Student ID is 10498614. IP. Internet Protocol IP is an address assigned to each device connected to a network and uses Internet Protocol and mainly used in layer 3 in OSI model. Here, the diagram shows clearly where the IP address sits. Next, the common use of Wireshark capturing real-time network data, importing data packets and text files, displaying, filtering and searching data packets, troubleshooting network problems. Now let's view how could we capture both the IP and net logs in Wireshark. On how to capture packets from an execution of traceroute. In order to capture the IP datagrams, you will require to use programs called ping plotter and traceroute, which is ping plotter, will operate sending TTL time to live value to the destination in the IP header, and the router return with ICMP message back to sender. To allow the tracings, the logs here are the steps. What you require is you have to select the first ICMP echo request message sent by your computer. Okay, right now in the TTL live exit transit TTL message, you will see the first IP address shown here is 10.0.0.20. That answers the first questions, which is the IP address from the client. Now moving to the next question, the value in the upper layer protocol field answers is 1. That is shown in protocol ICMP 1. So that answers the question number 2. Moving forward to question number 3. To identify the payload of the datagram, we will need the IP header, which header length 20 bytes. Now I'm showing it, the header length 20 bytes, and the payload of the datagram is the total length 56 minus the header length 20. It will give you 36 byte. Yeah, that's the answer for the question number 3. Moving next to question number 4. Has this IP datagram been fragmented? Looking at this and explain and how you determine whether or not the datagram has been fragmented. To answer this, if you drop down the flag fields, you will see that it shows fragmented offset 0. That confirms that the data is not been fragmented. Moving to question number 5, which field in the IP datagram always change from one datagram to the next within this series of ICMP message sent by your computer? If you see clearly, you will notice that the TTL value changes. Alright. Next, you can see the identification also changes, and this header checksum changes, but the rest remain the same for all the TTL. Here it's shown that the OXCDE6, the header checksum, changes for every TTL. To move to question number 6, which one of the fields must stay constant? Which fields must change and why? To answer this, you will now notice that the fields stay constants are version, header length, source IP, destination IP, differentiated services, and upper layer protocol. You can see now in the screen that the fields must change are identification, time to live, and header checksum. This must change. Let's move to the question number 7 now. Describe the pattern you see in the values in the identification field of the IP datagram. Here you will notice that you will see each identification field keep incrementing as it goes. The first identification is 15288. The next identification changes is 15289. The following identification changes 15290. That says that each identification field keeps incrementing as it grows. Let's move to question number 8. We require to get the first ICMP exceeded. Now that's the first ICMP exceeded reply. As we notice now, the identification field is 9613 and the TTL field is 64. Let's move to the question number 9. To answer question number 9, the identification field here changes, whereas the TTL field remains the same. The TTL remains as 64, but if you see, all the identification field changes to 9615, 9616, but the TTL time to life still remain as 64. Let's move to answer question number 10. First, sort the packet listing according to the time, again by clicking on the time column as shown on the screen, and then find the first ICMP echo request message that was sent by your computer after you changed the packet size in ping plotter to be 2000. Has that message has been fragmented across more than one IP datagram? The answer for this will be no, because we are using Wi-Fi instead of Internet. So for question number 11, 12 and 13 will not be existing. We will move to question number 14. In question number 14, it asked how many fragments were created from the original datagram. Here the answer will be 3 fragments created from the original datagram, because the first fragment is for 56, the second fragment will be for 2000, and the third fragment will be for 3500. Moving to question number 15, the last question for IP. What field change in the IP header among the fragments? The IP header fields that change between all the packets are shown here right now is the fragment offset. Next will be the checksum, which is OXA3DD, and between the first 2 packets and the last packet we see a change of fragment offset, checksum, and also the flex here. These are the 3 fields that changes between the 2 packets. To conclude this, thank you so much. This ends the assessment.